This is the exam review for Chapter 10. If you pick a marble, what's the probability that you pick a black marble? There are 2 black marbles. There are 12 marbles possible. So favorable over possible for all probability questions. That's for probability. For odds, it's favorable over unfavorable. So what's the odds in favor of a blue? Well, there's 5 blue, and there's 7 that are not blue. The odds against a black marble. Well, the black marbles are 2, so that goes on bottom. That makes the remaining marbles 10 of them. So we'd call that 5 to 1, or 5 to 1. Find the number of distinguishable permutations, the word parallel. We have 8 letters, so 8 factorial. A is written twice, so we say 2 factorial. L is written 3 times. So using our calculator, we could say 8 factorial divided by 2 factorial times 3 factorial. 3,360. So what that means is the number of ways you can move the letters around, and in each situation you'd be spelling out something differently. So if you just move the L's, that would spell the exact same word, and that wouldn't be distinguishable. But if you change the L and the A, then that would be distinguishable. We have 13 letters in perpendicular. P happens twice, so sometimes I like to put a P underneath that. E happens twice. The R happens twice. So with our calculator, we could say 13 factorial divided by 2 factorial times 2 factorial times 2 factorial. Lots of ways for this one. 778,377,600. Dairy-freeze, there are 12 sundae toppings. A regular sundae comes with 3 toppings. How many different 3-topping sundaes could be ordered? Well, the big question here is, does it matter what order the toppings get put onto the sundae? So order would not matter in this situation. So we'd say that it's a combination. We have 11, and we're going to choose 3 toppings. So we have 165. Sundays. In elementary school, we had 5th grade. The 5th grade is 12 girls and 15 boys. We're doing tug of war. We want to know in how many different ways can the girls hold the rope. So in this case, we would say order matters because we're trying to hold the rope. That's an arrangement. So these are permutations. So we have 12 girls, and we're going to choose 8 of them. So that would be 12 times 11 times 10 times 9 times 8 times 7 times 6 for 8 numbers deep. So you see that the number is pretty big. $19 million, almost 20 million. And in this case, we've had 15 P8. Here we have a cookie jar that contains a dozen chocolate chip, 7 oatmeal, 14 peanut butter. If you take a cookie and eat it, then select a second cookie, what's the probability? Remember, probability is always favorable over possible. So you got to have some sort of a fraction or a decimal that's less than 1. If you're going to eat it, that means you're not going to return it. So the first cookie is peanut butter. That was 14 out of a possible 33 cookies. And then chocolate chip, there's 12, but now there's only 32 cookies if possible. And we could take those two numbers and you could turn those into a fraction, and we see that that is 7 44ths. The first cookie is oatmeal, and the second cookie is peanut butter. We multiply straight across. We get 49 over 528. Next, we're going to have neither cookie is chocolate chip. So that means from the chocolate chip, there's 12 of them out of our 33. So that means there's 21 favorable non-chocolate chip cookies. And then after you eat one, there's only going to be 20 non-chocolate chips out of 32. So we have 420 out of 1,056. Which reduces to 35.88. Both are going to be chocolate chip. There's 12 chocolate chip to start with out of the 33 possible. Then after you eat one, there would be 11 chocolate chip out of 32. So that reduces to 1/8. The first cookie is oatmeal and the second cookie is not oatmeal. So if the first one is oatmeal, that's 7 out of 33. And then the second one is not oatmeal. So 7 away from 33 is going to be 26, but you ate one of them. So now I believe there's 25 cookies available out of 32. No, let me think about that again. There would be 33 cookies. And of the, take away the 7, there would be 26 that aren't. It still has 26 because we didn't eat one that wasn't. We ate one that was oatmeal, and then we're going to eat one that is not oatmeal. There's 26 that are not oatmeal, but there's only 32 possible. The number on your insurance card begins with 3 letters and is followed by 5 numbers. The letters and numbers can be repeated. We have, for all of these problems, we're going to have a letter, letter, and a letter, and 5 numbers. They can both be repeated. So there's going to be 26 letters in the alphabet. This is going to happen 3 different times. There are 10 numbers, 10 digits, 0 through 9. And we can have 5 of those. So a lot of different insurance cards can be made with that combination. Only the letters can be repeated. So the first number would have 10 choices, the second number would have 9, then 8, then 7, then 6 possibilities. Another way to write that would be 26 to the third power 10p5. That would mean the same thing. One, two, three, four, 5. And if neither number can be repeated, Another way to write that would be 26p3 times 10p5. Here we have the binomial theorem. So we'll start out with our 1, 4, 6, 4, and the 1 from Pascal's triangle. We take our a value to the 4th power, 3rd power, 2nd power, 1st to the 0. Negative y squared to the 0 power, negative y squared to the 1st power, to the 2nd, and negative y squared to the 4th power. Then we start to clean them up. Here we'd have x to the 4th. Here we get 4x cubed when you do it to the 1st power, you would still have that negative. But when you square a negative, you get a positive, and then y squared squared is y to the 4th. When you raise negative y squared to the 3rd power, you still keep your negative and you multiply exponents. X to the 0 would make a positive with the negatives and multiply exponents. So your final answer, the negative would go in front of the 4. The negative would go in front of this 4. Bring down your a value. Your b value with your pluses between. 3 cubed is 27. 3 squared is 9. To the 1st power just gives us 3x. So we get 27x cubed. Here we get 3 times 9, which is also 27, but that's x squared y. 3 and 3 is 9. Find the indicated probability. Determine if they're disjoint. Remember our formula. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So in this case, we'd say 8/11 equals 4/11 plus our unknown minus the and, which is 2/11. So you could call this 8/11. 4 minus 2 is 2. Subtract that to get 6/11 would be your B value. In this case, we'd start out with 5/6, 1/3, 1/2, and our unknown and value. Get our common denominators. So that means that there's 0 overlap. If there's 0 overlap, are they disjoint? And the answer is yes. In this case, the and indicates that there is overlap. So are they disjoint? Are they different from each other completely? And the answer is no. There's overlap. On the next page, for number 13, we have two events that are independent. So the probability of A and B. For and, you're going to multiply. So in this case, we're going to say 0.45 times our unknown, and that equals our and. So we're going to divide by 0.45. So 0.09 divided by 0.45, we get 0.2. So 0.45 times 0.2 is 0.09. So here, 6 times 8 is 48, and 2 decimal spots gives us 0.48. Our last set of questions. Find the probability of drawing the given cards in the standard 52 card deck. The pictures available for you. The first part, we're going to replace the card, and then the second part, we're not going to replace it. We'll keep it in our hand. We want a heart, then we want a diamond. A heart, there are 13 out of 52 cards. If you replace it, meaning you put it back in the deck, then you want a diamond, then there's 13 diamonds out of 52. If you're not going to replace it, there'd be 13 out of 52. Then there's 13 diamonds, but there's only 51 cards available. It's not dramatically different, but you see that there are 6.25% and 6.37%. A little bit more likely that you would get this situation if you did not replace it back into the deck. You want an A, then you want a face card, then you want a 10. And, well, A4. And the 4, there's 4 out of 52 cards. Face cards, there's 12 of them. And then a 10, there's 4 of them. If you're going to work without replacing it, you'd have 4 out of 52. To get a face card, that's different than a 4, so you'd still have 12 of those available, but only 51 cards because you've already picked a 4 out. A 10 is different than all of those because a 10 is not a face card either. So there's still 4 of them, but there's only 10, or actually 50 cards available. .0014. And our final question, a jack. There's 4 jacks. Then another jack, well, it would be 4 if you're not replacing. If you are replacing it. And then a third jack. If you're not going to replace it, you keep that jack out, so now there's only 3 out of the 51, and then 2 out of the 50. Okay, with this one, 52, 52, 52, well, let's take a step back. Let's look here. In the calculator, when I divided the 24 divided by 132,600, I got this E-4. That means you're going to move the decimal spot 4 times to the left, which gives you 3 zeros, and your 1/8. Up with this first part, it was actually 64 divided by 52 to the 3rd power, not 52 to the 2nd power like I typed it in the first time. So that would be 0.00046.